the y is equal to 10k multiplied by sine 30 degree, which is 5k, and the x is equals to 10k multiplied by cosine 30 degree, which is 8.66k. And you need to put these two forces on your free body diagram. So this is 5k, and this is 8.66k. And finally, because at point A is a fixed part, so this part is a fixed part. So it's a little bit different from the what we did before. So for a fixed part, there are three support reactions. So this one is AY. We have AY, AX, and we have another restriction. We call this MA. So it's a rotational support reaction, and we copy and paste to our free body diagram. So this is AY. So this is AX, and here we have MA. And this is a free body diagram. So this first step. So the second step is to set up the equilibrium equations, right? So first of all, let's do this sigma fx equal to 0. Remember, we have three equilibrium equations. So the sigma fx equal to 0 means that the sum of all of the forces in the x direction equal to 0. So if you look at our free body diagram, so which forces are in the horizontal direction or x direction? So we have this ax, right? So ax going to the right, so it means positive ax. And we have this 8.66k going to the left, so which means negative 8.66k equal to 0. So you got ax equal to 8.66k, and going to the right. And second equation, sigma m at A equal to 0. So it means that the sum of all of moment at A equal to 0. So what do we have here at point A? Because we already have a rotational support reaction MA, so we need to consider that in our equation. So, and this MA is going which direction? Counterclockwise, right? So it means positive MA. And do we need to consider the AX and AY? No, because the AX and AY are acting on our reference point. So which means we don't have to care about that. So, but we do need to care about this 10K, because this 10K will contribute moment at point A, and this 10K will rotate around point A in which direction? So it would go clockwise, right? So it will go like this. So it's clockwise. So clockwise means negative 10K multiplied by our distance, 5, right? 5 feet. And also we need to consider this 5K This 5K will also contribute moment at point A. And this 5K will rotate in which direction? Yeah, clockwise, still clockwise. So it's negative 5K multiplied by, 10 feet. And finally, we have this 8.66K. This will also contribute moment at point A. So this 8.66K will rotate around point A in which direction? Counterclockwise, right? So which means it's positive 8.66K multiplied by. So what is the distance in this case? Is it 3 or 10? Yeah, 3, right? Because whenever we talk about distance, we consider the perpendicular distance, right? So again, perpendicular means that two lines have to form a 90 degree, right? So this is your force. So which line can form a 90 degree with that line? It's definitely this line, right? So multiply by 3 feet equal to 0. So you can solve for MA is equals to positive 74.02 and going, so it's very important to include the unit here. So it's K feet and it's going counterclockwise because we got a positive answer. And finally, we have another equation, right? So sigma Fy equal to 0. So sigma Fy equal to 0 means all of the forces in the sum of all of the forces in y direction equal to 0. So which forces are in the y direction? So you got this Ay, right? Oh, you have a question?
So here and also you have sigma Fx. Why is it F?
F means force. F just force. So Fx means force. Force is in the x direction. So we call it.
So we use that whenever we're doing direct, like linear force as opposed to rotational or moment.
Yeah, exactly. So Fx means only the force, but M at A means that the rotational, force is moment, right?
Okay. So anytime it's linear, we annotate it as Fx or X.
Yeah. You can say that, yeah. Yeah.
Why did you assume that the unit is counterclockwise?
Oh, you mean the MA, right? That's a very good question. So you can assume it's a counterclockwise. Is clockwise. It doesn't really matter.
But if you assume it's clockwise, don't you get a negative?
Yeah, exactly. So whenever you get a negative answer, which means you need to crack the initial assumption. Because if you let's say initially you assume MA is going clockwise like this, right? If you assume MA is going clockwise, then you need to change your equation here, right? So in negative MA, right? You need to change your equation here. And then your answer will be negative 74.02, which means your initial assumption is wrong. So actually, the MA should be going in opposite direction. So which means in this case, you need to correct your initial assumption that the MA should be going in this direction. You understand?
Yeah, so negative just means it's the opposite direction.
Exactly, yeah. So let's continue. So Fy, sigma Fy equals 0. So which forces are in the y direction? So you have Ay is going upwards. So you use positive Ay. You have this 10K going downward. So negative 10K. And you have this 5K going downwards. Right? So it's negative 5K equal to 0. So you can solve for Ay equals to positive 15K. And you got a positive answer, which means it's going upwards. And which means your initial assumption is correct. So because you initially assume Ay is going upwards, so you got a positive answer. So Ay is indeed going upwards. Right?
We always round to the 100th place? Or we have a decimal?
It's better for you to keep the decimal at two decimal places. Yeah. And so this is this question. So do you have any question about this? So I can you guys can tell me which question you want to. So for this question, if you look at the structure, so we have an inclined load here. This one. But this time we don't have an angle, so we cannot directly apply for the apply the trigonometry for this inclined load. So instead of using the trigonometry, we need to use the ratio. So the ratio. So again, here we have inclined load, which is 12K, and you have another triangle. Can anybody tell me what is the hypotenuse of this the second triangle? 3, 4, what? 3, 4, 5, yeah. And our mission is to get y and x. So if you want to get y, you need to use this 12K multiplied by what over what? Yes, exactly. You're pretty good, yeah. So we need to use the opposite divided by the hypotenuse. So if you want to get x, so you need to use 12K multiplied by the adjacent divided by the hypotenuse. So in this case, if you want to compute for y, so you plug in this equation. So what is opposite? 3, right? Exactly. So if you want to compute for x, so what you plug in this equation, 12 multiplied by what over what? 4 over 5, right? And you got y equals to 7.2, okay? You got x is equals to 9.6K. And then you need to copy and paste these two forces on your free body diagram. So you have a 20K over here, and you also have a y component. So So that is 7.2K. And you have an X component, 9.6K. And don't forget, don't forget about our support reactions, right? So at point A is a roller support, so which means there's only one support reaction. So this is AY. Point B is pin support, so which means we have two support reactions. So B, Y, and B, X. And this is our free body diagram. So this is a free body diagram. And second, we need to set up the equilibrium equations. So first of all, let's say sigma Fx equal to 0. So which forces are in the x direction in this case? So our Bx, right, going to the right, which means positive Bx. And we have this 9.6K going to the left, which means negative 9.6K equal to 0. So you got Bx equals to 9.6K going to the right. And the second equation, sigma m at A equal to 0. So in this case, so for this equation, we just need to consider which force will contribute moment at point A. Does AY contribute moment at point A? Yes. No. Because this force, this force is already acting at our reference point. So this force will not contribute the moment at our reference point. But this 7.2K will contribute moment at point A. And this 7.2K will rotate around point A in which direction?
Clockwise.
Yeah, clockwise, right? So it's negative 7.2K multiplied by the distance, which is 5K, right? And the same thing, right? We have 20K acting at the same point, right? It's still going downwards. So it's same thing, so negative 20K multiplied by 5 feet. And we also have this 9.6K going to the left. So this force will rotate around point A in which direction? Yeah, counter, right? Yeah. So which means it's a positive 9.6K multiplied by, what is the distance? Yeah, 5, right? 5 feet. And then, what do we have here? So we have this By. So this By will rotate around point A in which direction? Counterclockwise, right? So it's positive By multiplied by the distance is 5 feet plus 5 feet, right? Which is 10 feet. And does this Bx contribute a moment at point A or not? No. Why? Because Bx will cross the point A, right? Which means this Bx will not rotate around point A because the Bx will cross the point A. So, which means the Bx doesn't really contribute a moment at point A. So we don't have to consider Bx in that equation. And finally, we make this equation equal to 0. And you solve for By is equals to 8.8K going upwards. And the final equation sigma Fy equals 0. The sum of all forces in the y direction equal to 0. So you got Ay, positive Ay, and you have this 7.2 K going downwards, 20 K going downwards, right? So negative 7.2 K going downwards, negative 20 K going downwards. And you have this By going upwards, and we already got By here, right? So we plug that number into that equation. So positive 8.8 K equal to 0. So finally you got Ay equals to 18.4 K going upwards. Does anybody have a question about this? Yeah.
Where did we get the 8.8 K for?
So you want me to solve this equation for you or
Oh, okay.
Yeah, yeah. Is there any other question that you want me to cover? 6? Okay. I'll wait for some. Anybody copy paste this one? So finish. Okay, so for the 6, it's actually the same thing, right? But this time, we have an inclined load here, and it has an angle. It's more straightforward because if we have angle here, we can directly apply for the trigonometry, right? And so here is the 12K. And you know the angle is 30 degrees. So this is Y. This is the X. And you know the angle is 30 degrees. So again, if you want to compute for Y, you need to use which equation? Is sine or cosine? Right, sine. So need to use 12K multiplied by sine 30 degrees. You got 6K. And if you want to compute for X, so you need to use cosine 12K multiplied by cosine 30 degrees. You got 10.39 K. And then you just copy and paste that number to our free body diagram. So this one is 6K. And we have 10.39K. And don't forget about we still have a 6K on the top. And at point A is a roller spar, which means there's only one spar reaction. So this is AY. At point B is a pin spar, so there are two spar reactions. So BY and BX. And this is our free body diagram. The second step still follow the same procedure. So set up equilibrium equations. So first of all, sigma Fx equal to 0. So again, so which forces are in the x direction? So you got this 10.39K going to the left, so negative 10.39K, right? You have this Bx going to the right, so you got plus Bx equal to 0. So you got Bx equal to 10.39K going to the right. And then second equation, sigma m at A equal to 0. So, so you just think about it. Which force will contribute moment at point A? So you have this 6K, right? This 6K will contribute a moment at point A. And this 6K will rotate around point A in which direction? Clockwise, right? So it's negative 6K multiplied by distance, 5 plus 5, which is 10 feet. And you have another 6K here. Right? And this 6K will also rotate about point A in which direction? Clockwise, right? So it's still negative 6K multiplied the distance, which is 5 plus 5 plus 5, which is 15K. And then you have this 10.39K. So this 10.39K will rotate around point A in which direction? Yeah, counterclockwise. So, which means it's positive 10.39K multiplied by the distance. So in this case, distance is what? Is 5 or 15? Yeah, 5, right? Because we look at the perpendicular distance. So this is our perpendicular distance. 5 feet. And finally, we have this By. So this By will contribute, will rotate around point A in which direction? Yeah, counterclockwise. So it's plus By multiplied by the distance is 5 plus 5 plus 5 plus 5 plus, it's 20 feet, right? And make this equation equal to 0. So you got Vy equals to 4.9. Okay, going up. And then our final equation is sigma fx equal to 0. Sum of all our forces in the y direction equal to 0. So you have Ay going upwards. So it's positive Ay. You have a 6K going downwards. So negative 6K. Another 6K going downwards. Negative 6K. You have this By going upwards. Plus, because we already got By above here. So you plug the number into this equation. So plus 4.9K equal to 0. So you got Ay is equals to 7.1K going up. Any questions about this one? So, is there any other questions that you guys want me to show? Yes. Oh, question 4? Okay. So, this one still inclined load. right? So in this case, still we need to break this down into two components, x and y. So this is y. So this is x. So again, if you want to compute for y, you need to use sine theta. So y equals to 12k multiplied by sine is 6 degrees. And which is equals to 10.39k. And if you want to compute for x, you need to use the cosine theta. So in this case, it's 12k multiplied by cosine 6 degrees. You got 6k. And then you can just draw the free body diagram here. So and copy and paste these two numbers. So y is equal to 10.39k. So x is equals to 6k. And again, so our, at point A is a p spark, so there are two spark reactions. Call this AY and AX. And point B is a roller spark, so there is only one spark reaction. So this is BY. So this is our free body diagram. So step number one. So step number two, just again set up our equilibrium equations. So first one is sigma fx equal to 0. So which forces are in the x direction? So you got ax going to the right. So positive ax. You have this 6k going to the right, going to the left. So it's negative 6k and equal to 0. So you got ax equal to 6k going to the right. And second equation, sigma m and a equal to 0. So which force will contribute moment at point A? You have these 10.39k, right? So this 10.39k will rotate around point A in which direction? So if you don't really know how you will rotate, so you draw like me, so it's like this, right? So it's clockwise, right? So because it's clockwise, then it means negative 10.39k, right? And the distance is 4 feet. And then you have this by. This by will contribute moment at point A, and the by will rotate in which direction? So again, if you don't really know, so you can draw like me. Right, it's like this. So it's counterclockwise, right? So plus by multiplied by the distance. It's 4 plus 8, which is 12 feet. And you got by is equals to 3.46, okay, going upwards. And finally, you got sigma fy equal to 0. So which forces are in the y direction? You got ay going up, so positive ay. You have this 10.39k going down, minus 10.39K. And you have this BY going upwards. And we already got BY above here. So plug that in. So you plus 3.46K equal to 0. So we got AY equals to 6.93K going up. Three? Oh, okay. Okay, let me do question 3. Because question 3 is a triangular load, right? So this one. So whenever you see a triangular load, you need to convert the triangular load into a resultant force. So again, so the magnitude of the resultant force is the area of this triangle. So what is area of this triangle? Is a half multiplied by 2 multiplied by 6, right? Which is 6K. And another thing, important thing, is that you need to know the location of this resultant force. So, which means you need to know the centroid of this resultant force. So for a triangle, the centroid is at the one-third from the left end, or 2/3 from the right end.
Sorry.
Yeah.
Is the centroid always 2/3 from the obtuse angle or the oblique angle?
Yeah. So it's 2/3 from this. From here, I would say the sharp end, right? Or 1/3 from the end with the 90-degree angle.
So it's always going to be that for this side.
Yes, exactly. Yes.
Okay.
Yeah. But yeah, this only for this rule only apply for the triangle with 90 degrees. But what if there's a triangle like this? So the centroid is at middle, right? It's not the 2/3 or 1/3, something like that. Because this rule only applies for there's a triangle with there's 90 degrees, right? And after you convert the triangular load into a resultant force, you can just copy and paste to our free body diagram. So this is a 6K, and the location is 1/3 from the point A, which is 1/3 multiplied by 6 equals 2 feet. Right, and point A is a pin support, which means there are two support reactions. So this is an AY, this is an AX, and you have another 6K right there. Copy and paste. So this is 6K, and for point B is a roller support. So there's only one support reaction, so it's BY. And this is our free body diagram. So for the second step, set up our equilibrium equations. So again, the first one, sigma Fx equals 0. So which force is in the horizontal direction? Only Ax, right? Which means Ax has to be 0, otherwise the structure will be unstable. There's no other force to balance this Ax. So Ax has to be 0 to make the structure balanced. Right? So The second equation is sigma m at A equal to 0. So you should look at which force will contribute moment at point A. So you have this 6K. And this 6K will rotate around point A in which direction? Clockwise, right? So it's negative 6K and multiply distance. We already got distance is 2. I'll write down y is 2. Y is 2 is 1/3 multiplied by 6. Right? So 2 feet. And you have this another 6K will contribute moment at point A. And this 6K will rotate around point A in which direction? Again, clockwise. So negative 6K multiplied by the distance. The distance from your reference point A is 6 plus 2, which is 8 feet. And finally, you have this BY. This BY will rotate around point A in which direction? Counterclockwise, right? So again, if you don't know, you can draw like me. So you will rotate around like this, right? So plus BY multiplied by distance. 6 plus 2 plus 2, which is 10. Equal to 0. So you got BY equals to 6K going up. And finally, you got sigma Fy equal to 0. So which velocity are in the y direction? You have AY going upwards. You have 6K going down. You got another 6K going down. And you got BY, already got BY above. So plug that number in to our third equation. So equal to 0, so got AY is equals to 6K going up. Yeah, so if you have any question, just let me know. And yeah, you're free to go. So if you don't have questions, so oh, question 7, okay.